Hi there, welcome to our video on scientific notation in the context of business. Scientific notation is used to express very large and very small numbers efficiently. And when I say efficiently here, I mean efficiency of display, so visual efficiency. These kinds of numbers occur frequently in business because sales revenue, capital outlays, those kinds of things might be in the millions or more. Manufacturing tolerances, on the other hand, might need measurements within a millionth of a meter, very, very tiny. And these are just a few examples. Because you'll be using spreadsheets like Excel or calculators to handle numbers in this context, you need to know about scientific notation because these large and small numbers are going to come up. Even if you choose not to use it when inputting numbers yourself, scientific notation will nevertheless arise in the answers because all computers these days will just freely, willy-nilly put things into scientific notation, and they do that in order to preserve the readability of their displayed output. So you're going to read scientific notation whether you like it or not, is what I'm saying. And this lecture is here to help with that. So figure 7 shows the number 82,300 in scientific notation, written in the classical way, which is 8.23 times 10 to the fourth. Now figure 7 splits this notation into three parts. The first part, starting with the left, this is always going to be a number between 1 and 10. Technically between 1 and 9.99999 decimal repeating. Once you get to 10, you would move the decimal place over one more. Notice that the 8.23, those are the same numbers as 823 in the 82,300 original notation. This part in scientific notation can have any number of digits after the decimal, but it's often rounded for display. So I've rounded it to 2 decimals here. Actually, I didn't round it because there were no non-zero numbers to the right of the 3. You could leave 4 digits on, you could leave 7 digits on, you could leave 1 digit on, you could leave no digits on, depending on the purpose for which you are reporting this number and the original number itself and how many trailing or leading zeros it has. The second panel in figure 7 just shows a multiplication sign, and that is your normal multiplied by or times sign. The third panel shows 10 to the fourth, so that's 10 to the fourth power. 10 to the fourth power is 10 times 10 times 10 times 10, okay? But in scientific notation, it's always written 10 to a power. And this is the part that's going to tell you what happens with that decimal place in scientific notation. So this part is always the number 10 with an exponent, which is always a whole number. The exponent can be positive or negative. So for large numbers like 82,300, your exponent is going to end up positive in scientific notation. For small numbers like 0.000023, your exponent on the 10 is going to end up being negative. We're going to go through examples of both. Nowadays, though, you are more likely to encounter scientific notation with a slightly different look because computer displays do not go for superscripts. In Excel, 82,300 in scientific notation would look like this. Or equivalently, it could look like 8.23 capital E plus 04. So how is that scientific notation related to the notation in figure 7? Well, figure 8 shows the parts and their meaning. So looking at figure 8, which shows the more modern scientific notation, the left panel still shows the 8.23 and nothing about that has changed. The E in this expression means times 10 to the. So in mathematical notation, that E is actually taking care of the times 10 and the caret. That would signify the exponent. Looking at the right-hand panel, we have plus 04. That is the exponent on the 10. This exponent can be positive or negative. In this case, it's positive. You can see the plus sign there, but if you didn't have the plus sign, you would assume that it's positive, and that is how numbers work. The leading zero is not required, but it is customary, and you'll see that Excel will add it to its own display if you do not type it in. However, writing plus 4 or just 4 would be equivalent to writing plus 04, or typing plus 04. So now that we know what scientific notation looks like, and I am going to use both the classical version and the modern version of scientific notation, how do you go back and forth between the two? And what does it mean that 82,300 is the same as 8.23e plus 04 in scientific notation? So let's take a look at example 3.1 to talk about this a little bit. Just discuss, it doesn't say discuss, but we're going to talk about 82,300 in scientific notation. So the first thing I'm going to do is write 82,300. And I'm going to point out that there is an implicit decimal in this number, although it is not showing. The implicit decimal is right here, right? The reason that that decimal isn't written is because this number is a whole number, and so that it means there's nothing but zeros off to the right, nothing but zeros. And so in that situation, often the decimal is just left off. But in this case, we're dealing with scientific notation, so I want to talk about that decimal. Now, look at this part of the number in scientific notation, that first part, 8.23, right? 8.23. So how are we going to get there? Well, I am going to take my decimal points, the decimal point I just wrote in, and I'm going to hop it once to the left. That puts it between the two zeros. I'm going to hop it twice to the left. That puts it between the 3 and the 0. Then I'm going to hop it 3 times to the left, puts it between the 2 and the 3. Hop it 4 times to the left, and it is between the 8 and the 2, and that is where I'm going to put it for my scientific notation. What I just did was I transformed this number, 82,300, into a number that is between 1 and 10, right? 8.23. So you hop your decimals as many places to the left as you need to get it so there is only one digit to the left of the decimal. That's going to put you between 1 and 10. Now notice I was counting those hops, right? I was counting those hops, and that was on purpose. So I'm going to rewrite now 8.23 with the decimal into its hopped place. But in order to tell the people what we've done, that we've taken the original decimal and we've hopped it 4 places to the left, I'm going to say I multiplied it by 10 to the 4th as its exponent, and that 4 indicates those 4 steps that we took. Now remember, this could be written, this is equivalent to 8.23E4. You could write it that way. You could write 8.23E04. You could write 8.23E positive sign 04. All of those are writing the same thing. So I mentioned in our discussion of the figures above that 10 to the 4th is 10,000. So the way we get 82,300 back is by just doing this math problem. 8.23 times 10,000 equals 82,300. You can try it yourself with a calculator or with Excel. Now, we use this hopping decimal as an explanatory technique to get into scientific notation. I want to show you how to use it to get out of it as well. So we spelled out that scientific notation is literally just a math problem, right? When it's times 10 to the something, that's going to be 10 or 10,000 or 1 over 10 or 1 over 10,000 or something like that. And you are going to end up multiplying your first part by that number, and it's going to move the decimal place to where it ought to be. But what if you started out with 8.23 times 10 to the 4th? If you were going from 8.23 times 10 to the 4th to 82,300, how could we get there? Well, I'm going to rewrite that 8.23. That's my original part that's containing my numerical information about this number we're going to end up with. And then I'm going to look at this 4. It's a positive 4, so I'm going to hop my decimal in a positive direction to make this number bigger. Hop it 4 times. Hop it once, puts it between the 2 and the 3. Hop it twice, puts it here. Hop it 3 times, puts it here. Hop it 4 times, puts it here. That's where we stop because 4 is the exponent. Put the decimal there. And now fill in the spaces with zeros. And you get 82,300 back.